All right, dive buddies, ready to go deep. Today, we're diving into AI image generation. You know those GANs, the ones making those crazy realistic faces or those amazing landscapes? But here's the thing. We're tackling a research paper, and it's tackling a big problem. How do we get these AI artists to create this stunning work, but without needing tons and tons of data to learn from? Because right now, most GANs are like that friend, the one shows up at the potluck and just eats everything in sight. But they only brought like a tiny little dish. They devour these massive data sets, millions of images sometimes, just to make something decent.
Yeah.
I mean, talk about a data buffet.
Right.
So the paper we're diving into today, it's called Get This, Differentiable Augmentation for Data-Efficient GAN Training. And it's all about making GANs, well, way less data hungry.
Yeah. And, all this data gluttony, it boils down to how these GANs learn, right? So picture this. You got two parts to a GAN. The artist, that's the generator, trying to make a masterpiece.
Right.
And then you've got the critic, the discriminator, judging, okay, how real does this look?
Yeah, like, are you good enough to hang on my digital fridge?
Exactly. Now, the critic learns by comparing the artist's work to real-world examples. But, and here's the catch, give that critic a tiny photo album to study, and they'll just start memorizing every little detail instead of getting what makes a good photo, in general.
Yeah, so they become like a master forger, right? They can copy those specific photos perfectly, but ask them to judge a totally new picture, they're clueless.
Exactly. They ace the memorization test.
Yeah.
But applying that knowledge to the real world, forget about it. And that, my friend, is the dreaded overfitting problem in AI.
And that problem, it gets even worse when you're working with limited data, right? Like, if you only have a handful of photos to show the AI, it's going to overfit even more.
You got it. So in this paper, the researchers, they took a really strong GAN called BIGAN.
Okay.
Think of this as a seasoned artist, right?
Right.
They trained it on this data set called CFAR10. Now, CFAR10's got all these images of everyday objects.
Okay, so we got our artist, we got our collection of photos. What happened?
Well, even with all of CFAR10, right, the whole thing, BIGAN's critic, that discriminator, it struggled to generalize. It's like you give it a whole textbook to study from. But then on exam day, when the questions require actual understanding, not just regurgitating facts,
It's a no-go.
total flop.
Yeah.
See, they measure this using something called, it's a mouthful, validation accuracy. It basically checks how well the AI does on images it's never seen before.
It's like a pop quiz for AI.
Exactly.
And how badly did Biggins' critic bomb?
Let's just say there was a big difference between how well it did on the training data, that's the stuff it already saw, versus the unseen stuff. Basically, memorized the textbook, but didn't learn the subject.
So not exactly setting the AI art world on fire.
Not even close.
So how do we fix this overfitting problem? Because just throwing more data at it, I mean, that's not always possible, right?
You're telling me.
Or effective.
Right.
So what do we do?
So AI researchers, we got a few tricks up our sleeves, right? And one of the classic techniques is called data augmentation. Basically, imagine taking those photos and making some subtle changes. Like rotating them a bit, maybe cropping them differently.
You're showing the AI different, like, perspectives on the same object. So it's not just memorizing every pixel. It's actually, like, picking up on the bigger pixel.
That's the hope.
Yeah.
But, and this is a big deal, but applying this directly to GANs often backfires. Spectacularly.
What do you mean? Like, what kind of chaos are we talking about here?
Think images with wacky colors, weird holes, or like they've been through a digital blender. The paper actually shows some visual examples. Figure 5A, not pretty.
Ouch, yeah, those images definitely belong in the AI art hall of shame. Okay, so if just augmenting the data doesn't work, what did the researchers try next?
Okay, so we've got our AI artists. They're stuck in this rut. Can't escape those limitations of small data sets. And we tried throwing more images at it, augmented images, but that just made this big old digital mess. So what's the answer? Did they actually find a way out of this AI art studio disaster?
They did, yeah.
Okay.
It's like magic, but, differentiable magic.
All right, you're going to have to explain that one to me. Differentiable magic. It sounds like we're about to go like full-on AI jargon here.
No, don't worry. It's not as crazy as it sounds. So I remember earlier we were talking about how these cans learn, they do this whole trial and error thing, right?
Right.
And they use this feedback, it's called gradients, to kind of adjust and make better images.
So gradients, think of those as like the AI compass.
Okay.
Pointing the model in the right direction to create, those beautiful images.
So gradients are helping the GAN navigate the wild world of AI art, But how does that fix our little augmented image problem?
Well, those distorted pictures we talked about, right? With the weird colors, the holes.
Right.
They messed up the AI
Yeah.
compass.
Okay.
The gradients, they couldn't flow properly from those like messed up images back to the generator. It's like you're trying to follow a compass that's just spinning wildly, totally out of control.
Yeah, no wonder our images look so wonky. So how did they fix the compass, this differentiable thing?
Okay, so they came up with this technique, right? They call it diff-augment.
Okay.
And here's the genius part. They made the augmentation itself differentiable. In other words, they made it compatible with those gradients, right?
Yeah.
So now that AI compass, it actually works even with the augmented images.
So instead of confusing the AI, these differentiable augmentations, they're actually guiding it,
Yeah.
right?
Yeah.
Helping it learn from all these different variations without getting lost in the distortions. It's like giving our compass like a PhD in understanding the terrain or something.
Exactly. It's like teaching an art student to recognize like the same object from different angles, maybe under different lighting,
Right.
even with different artistic styles.
It's expanding the AI's artistic vocabulary without sacrificing the quality of the work. That's really cool. But did it work? I mean, it sounds good in theory, but did this diff-augment actually deliver the goods?
Oh yeah, it did. And the results were pretty impressive, I have to say. So they tested diff-augment on all kinds of data sets. ImageNet, CFR10, a 100, FFHQ, LS1CAT, you name it. They even tried different GAN architectures, varied the amount of data.
They really put it through its paces.
They did.
So what happened? Was it the art world revolution we were all hoping for?
He was pretty darn close.
Okay.
So they use these, standard ways of measuring how good the images are, how diverse they are.
Okay.
They call them FID and IS.
Yeah.
And basically across the board, diff-augment made the images better, especially when they were using, those smaller data sets.
So it solves the weird-looking image problem, but then it also makes the AI way more efficient with the data it has to work with. It's awesome.
Oh, win-win.
Yeah.
And this has huge implications for something called, get this, low shot generation. Basically generating these amazing images from just a few examples.
Okay, hold on. So you're saying we could be making these photorealistic images from, like, a single photo album.
You got it.
That's insane. But before we get too carried away, we do have to talk about overfitting, right?
Of course, yeah.
How do we know that with these tiny data sets, the AI isn't just copying those few examples it has instead of actually learning and making something new?
That's a great point. And, the researchers, they were really aware of this issue. They looked at those generated images really, really carefully, and they found that they were actually very different from the training images.
So no AI art forgers here, just pure, unadulterated creativity.
Exactly.
This diff-augment thing is starting to sound like a real game changer, I have to say. Yeah.
But before we go crowning it, the next big thing in AI art, let's take a little pause and then we'll come back and talk about what this all means, like the bigger picture. Okay. All right, so we're back, and we've been talking about these data-efficient GANs, the AI artists that don't need a giant feast of data to create awesome stuff. But I got to ask, what's the big takeaway? Are we just talking about making prettier pictures here, or is there something more?
Oh, it's way bigger than just pretty pictures.
Okay.
This research, it could change the whole future of AI,
Huh.
Right now, having huge data sets, it's like the golden ticket.
Yeah.
You need those mountains of data to train the best models.
Like that old saying, you need money to make money, but in this case, it's you need data to make AI.
Exactly. And
Yeah.
that creates this barrier to entry. Smaller companies, individual researchers, artists.
They don't have those resources to build these insane data sets.
Yeah. So it's like this digital divide. Only the folks with the most data can play in the AI game.
Yeah, basically.
Okay.
But imagine, right, a future where you don't need those mountains of data to create something amazing with AI.
Okay.
That's what's so cool about diff-augment and these other techniques,
Yeah.
making AI more accessible.
Democratizing AI, it's like giving everyone the same set of tools, no matter how big their studio is. I like it.
Right. Think about it. Artists could be out there experimenting with AI-generated art without needing, Google-level data sets.
Right, right.
Researchers could make breakthroughs in fields where data is, really hard to come by.
Oh, I see.
Like rare diseases, think about it.
Yeah, well,
Or studying historical artifacts.
Right. The possibilities are huge. So where do we go from here? What's next for diff-augment?
Well, remember those simple augmentations we were
Yes.
talking about, rotating the image, cropping it? They're great, but imagine if the AI could learn even more advanced ways to augment the data.
So the AI becomes its own teacher, figuring out how to learn best.
Exactly. We call this learned augmentation, and it could make Defogmont even more powerful.
So we're not just giving the AI a paintbrush, we're giving it the whole darn art supply store. Let's see what they come up with.
Right?
It's exciting stuff. But it does make you wonder, if we can do all this now with these basic techniques, what happens when we really unlock the power of AI to learn for itself? Could we get to a point where these massive data sets, they're not even necessary?
That's the million-dollar question.
Yeah.
And it's something researchers are, actively working on. But this research, it's a good sign,
Yeah.
It shows us what might be possible, a future where we're not limited by data.
A future where the power of AI comes from the ideas, not just the amount of stuff we feed into it.
That's it.
That's a future I can get behind. And that, my friends, is what we call a deep dive. Thanks for coming along.